In pressure chapter, basically, we started with the basic idea of pressure in solids. So the basic definition of pressure is force acting per unit area. Pressure is equals to force upon area. This was the formula that we discussed. And secondly, the SI unit of pressure is Newton per meter square, or you can also use pascals, PA in short form, for pressure. So we can use both units. If you write pascals, that is also okay. And if you write Newton per meter square, that is also fine. But mostly in questions, we got pascals SI unit, right? So you can also write pascals every time in your SI unit for pressure. And according to the formula, pressure is directly proportional to the force. If we increase the force, pressure also increases. And it is inversely proportional to the area of the object. It means if we increase the area of the object, so pressure decreases. So according to this idea, we can relate pressure with force and the area of the object. So this is the formula for solid. Pressure is equals to force upon area. And for liquids, we have different formula, because in liquids, we know that there is no specific particular area of liquids. Liquid can be contained in any container. So for that container, we consider the volume of that container. So that's why force upon area is not exactly applicable on the pressure in liquids. So for pressure in liquids, we use different formula. P is equals to rho GH. The symbol of rho represents density, and G represents the gravitational field strength, that is 9.8. And the value of H is equals to depth. And according to the factors, we know that all factors are directly proportional. Like if we increase the density, so it will also increase the pressure. If we increase the value of G, it will also increase the pressure. And if we increase the depth, so that will also increases the pressure. So increasing all the factor will increase the pressure in liquids. And this is also simple formula. Unit remains the same, pascals for any type of pressure. The third topic we discuss is about atmospheric pressure, because in our atmosphere we have air particles present, and in rest state we not feel that air pressure, because we have air particles inside our body, because when we inhale, so we take that air particles inside, and when we exhale, so it comes out of our body. So when we start running, so during running, we observe that air particles are acting on our body with high force. So that creates the pressure on our body, and then in the running state, we can observe the air pressure exerted by the air particles. And for example, if we consider object in a liquid, so this is object in a liquid at certain depth. So because of liquid, we have pressure in liquid. So there is pressure of liquid acting on the object, plus we have atmospheric pressure also. This ATM actually represents atmospheric. P represents pressure. So atmospheric pressure plus pressure in liquid, that will give you the total pressure acting on the body. And this is the constant value of atmospheric pressure. This will remain same at sea level, the level on which we are living. So that is called sea level. So at sea level, atmospheric pressure value remains the same. And further, if we continue after this topic,
Sir, could you show the page again? I just want to check something.
okay.
Then, sir, thank you.
Okay, next concept is for example, we are talking about atmospheric pressure, and this atmospheric pressure is at sea level. This pressure value is at sea level. It means the level or the surface on which we are living, that is called sea level. But for example, if we move to some altitude, for example, if we move to some mountainous area, so definitely the distance from the earth increases, and the value of the height also increases. So in that case, what will happen with the atmospheric pressure? So let's see. So if we talk about atmospheric pressure at altitude. So if we talk about atmospheric pressure at altitude, so altitude means at a certain height from the sea level or from the ground. If we observe atmospheric pressure mostly on mountains or some mountainous area, so in that region, what do you think atmospheric pressure will increase or decrease? If generally, because we observe when we move to the mountainous area, so we observe that in our surrounding, it will become difficult for you to breathe or it becomes easy for us to breathe at mountainous area.
Becomes a bit difficult to breathe.
Yes, it becomes difficult to breathe over there because the value of atmosphere in our surrounding changes. So that is the factor we have to discuss, that what will happen at that stage and what are the reasons behind it. So basically, atmospheric pressure decreases at altitude, and it decreases as at altitude. The first reason is because of low density. The first factor is about density. uh, just like the liquid, if we consider the gases, so heavy gases are on ground level, like on earth, nearby earth's surface, and light gases are on the top. So we have different layers of gases. So for example, if we generally observe, so we have layer of dense gases nearby Earth's surface. And if we move at altitude, so we have less dense gases. So in the same way, when we move towards the altitude or at certain height, so we are moving in the region of less dense gases. So at this height, we got less dense gases, and that's why the first factor is about density. Density is for the gases, not for liquid. Right now, we are not talking about liquid. We are only working with the gases. So the first factor is density of gases are less at altitude. And how to explain that density is less? So basically, when we are talking about less dense gases, so gas particles are away from each other. So gas particles are away from each other in that case gases at altitude. That's why the atmospheric pressure decreases over there. And the second factor is about temperature. So the concept of temperature can be explained that because of low temperature, gases have or low temperature at altitude. And because of low temperature, particles collides particles collide less frequently because of low temperature, and they have less kinetic energy. So these are the two reasons if they ask in exam that what are the factors or how atmospheric pressure decreases at altitude. So the reasons are simple. The first reason is that because of density, and the second reason is because of temperature. So these are the two factors only in our syllabus that we need to know about atmospheric pressure at altitude. And after this, if we consider pressure exerted by the gases, right now we are talking about the atmospheric pressure, the gases present in our atmosphere. But for example, if we talk about the general category of the gases, if we contain any gas in any container, so how that gas exerts pressure on the container. So the second topic is about gas pressure exerted by the gas in terms of momentum and forces. And this question is like a repeated question in past papers also. Question is how gas particles exert pressure on container in terms of momentum and force. So basically, in your answer, you need to include the concept of momentum and also the concept of the force. We discuss momentum topic before the pressure. Momentum is the product of mass and velocity. So when we are talking about any particle or any object that has mass and moving with some speed, so the combination of mass and velocity is equals to the momentum. So when we are talking about the combined effect of mass and speed or mass and velocity, so that is called momentum. And also we discussed that rate of change of momentum is called force. So if we explain this idea, so answer can be defined as, let's suppose if we increase the temperature of the gas, when the temperature of gas is increased, the kinetic energy of particles increases. So first of all, if we increase the temperature of the gas, so kinetic energy of the particle also increases. And when the kinetic energy increases, so they starts to move more frequently, or they starts to collide more frequently. Particles starts to collide more frequently with neighboring particles and walls of container. So when particles get more kinetic energy, they starts to collide with the neighboring particles in a container, just like when we start to boil the water. So bubbles are going to form in the water because particles are getting energy. They starts to collide with the neighboring particles and the wall of the container also. And definitely when they collide more frequently, so they are exerting more force on particle and wall of container. Particle exert more force on walls of container, and when they collide with the wall of container they also bounce back. So when they bounce back from wall, so just like in the topic of momentum, we discussed momentum is a vector quantity. So when the direction of particle changes, so due to the change in direction, momentum also changes. So when it bounces back from the wall, momentum also changes. And rate of change of momentum is equal to force and equation F is equals to P over T. This triangle sign is delta sign. Delta sign represents the change. So change in momentum is equals to the force. And according to the question, it is mentioned momentum and force. So we include momentum and force in our answer. And when force is acting on the container wall, so definitely force per unit area is equals to the pressure. And force acting per unit area is called pressure. So this is the complete descriptive answer for this question, but we don't need to write whole answer every time. It depends upon the question. Sometimes they only ask for 2 marks, sometimes they used to ask for 3 marks. So we will write in the paragraph according to that marks given in the question. We will discuss the question also, like how we will get the question in the past papers and how to solve them. So a long vertical tube sealed at the base and open at the other end. The length of tube is 1 meter and cross-sectional area is also given. Density of liquid is also given. So density is given, area is given, length is given. Atmospheric pressure, you can see constant value that is also given in the question because it remains same. And in the first part, you have to calculate the total pressure in the liquid at the bottom of the tube. So how to calculate the total pressure in the liquid at the bottom of the tube? So according to the diagram, the tube is open from the top. So when tube is open from the top, it means that atmospheric pressure easily exert from the top side because it is open to the air. So air particles are acting pressure on the liquid also. And on the base of container, we know that pressure exerted by the liquid is also acting on the base. So just like the notes we discuss, that when something is in the liquid surface, so we have to find out the total pressure by adding up the pressure in liquid and pressure of atmosphere. So right now we have pressure in liquid and pressure of atmosphere. And the question is to find out the total pressure in liquid at the bottom of the tube. Total pressure is equals to pressure in liquid plus atmospheric pressure. The formula of pressure in liquid is same, rho GH, and the value of atmospheric pressure is constant. And the density of liquid is given. Okay. So density is 1.4 exponent 4 kg per meter cube. The value of G is constant, 9.8. And for height, it is given that the total height of the tube is 1 meter. So that will be equals to 1 plus atmospheric pressure, which is constant. So now you can calculate with calculator the final value of the total pressure acting at the base of liquid.
Uh, Sir, this model T with the P represents.
That is total pressure.
Oh, okay.
So first of all, we have to multiply all three quantities, 1.4 10 to the power 4 multiply 9.8 into 1. So we got answer 1.3, or in simple words, we are getting answer 137. And when we add with 1 10 to the power 5, it becomes 237,200 pascals. Or you can also write your answer in scientific notation, or another way to write your answer is to round off to two significant figures. This is another way to write your answer. And we have one more choice to write this answer, 2.4 10 power 1 2 3 4 5 pascals. So we have different way to write down the answer. We can write in two significant figures like 24,000, and we can also write in scientific notation like 2.4 exponent 5. So it's up to you how you are going to write your answer. All answers are acceptable.
Sir, can you like show the diagram again?
This is the diagram.
Sir, how I just wanted to ask how would we put the equation into the calculator like that?
Okay, if you have a scientific calculator, so in scientific calculator, first of all, if we have value like 1.4, so in 1.4, you can just simply write 1.4, and after that I will show you, because in simple calculator you will not get that button. So you have to use scientific calculator, that is allowed in your papers also. Especially for physics. In maths, you know that in paper 1, I think calculator is not available for calculation, so we have to do manual, but in physics, calculator is allowed. So I'm sending you the picture of the button that you have to press for power.
Okay, sir.
You have different types of scientific calculator, but you will find that button in your calculator also.
Okay, sir.
Sir, can you explain how you got 9.8?
9.8 is a constant value. The value of G, that is
Okay.
constant. That is always given on the top of your paper in instructions.
o-
Yes, that
Okay,
will
sir.
remain same and given in the paper. In old papers, we use 10, and in new papers, we have to use 9.8 mentioned in the paper also. So I send the picture of the button of the calculator. Like if you are calculating 1.4, you have to type 1.4 and then you need to press this button. You will automatically get uh, cross 10 and then you write power 4. I will also send you a recording that how to perform this calculation in your calculators, because we have scientific calculators in phone also, but in final exam you have to calculate with calculator because phones are not allowed there. So let's suppose we got value 137,200 plus 1.0, then press exponent button, then 5. So you will get final answer, right? So I am sending this one also. Okay, I also shared the video for calculation. So you can get reference from that. You just need to simply press the button. You will automatically get all the values from the calculator. You don't need to perform any manual calculation. So still, if you have any confusion in calculation from the calculator, you can ask again. Then we will move towards the next part of the question.
Sir, 9.8 is a constant value of.
The value of G, gravitational field strength.
Oh, okay, sir. Okay. So 9.8 newtons. Okay.
So this is constant value. It is always given on the top instruction of the paper. So any confusion in calculation from calculator? Okay. In the second part, we have to calculate the force exerted on inside surface of the bottom of the tube. So to calculate the force, we know that we have only one formula. Pressure is equals to force upon area. And when we shuffle the values, so A cross multiply on the other side. So force becomes pressure into area. So the value of pressure, we calculated the total pressure. We have to use total pressure right now because we have total pressure. They are also talking about the same thing, bottom of the tube. So we already calculated bottom of the tube pressure. So the total value is 2.4. And area is given in the question. Area is 4.0 10 to the power minus 4. So now multiply these two quantities and let me know what is the final answer you are getting from calculator.
The F and A stands for?
F represents force, A represents area. This is the basic
Okay.
formula for the pressure in solid, force upon area.
Okay, sir.
So calculate the force and let me know the answer, what answers you are getting from the calculator after calculation.
Sir, where do we send the answer to you?
No, just tell me the answer. You can write in the chat, so it will help to identify that from calculator, are you getting a right answer or not?
Okay.
So for simple calculator, these are for simple calculator. So let's suppose if you have positive power given in your value, so you need to write that value in simple calculator by shifting that decimal point on right hand side. So we have power 5. It means we have to shift a decimal point 5 times. So let's suppose we have 2.4. So you have to shift this decimal 5 times, like 1, add 1 0, then 2, add 1 more 0, 3, 4, 5. So we got 1, 2, 3, 4, 5. 5 decimal points. So final answer is equals to 2, 4 and 5 zeros. So in this way, you can write this value in simple calculator. And for example, if your power given with the quantity is negative, if we take example of this value, minus 4. So we need to shift decimal on left hand side. Left hand side. So we have value given 4.0. So we have to shift on left hand side and power is 4. So 4 times shift. We have 1, 2, 3, 4. So when we shift 4 times, it becomes 0.0004. So in this way, you can convert your values into simple notation and then calculate with the help of simple calculator. So if you have negative value given, so you have to shift decimal according to the given number in the power on left hand side. And if you have positive value given in the power, so you have to shift the decimal with the same number given in the power on right hand side. So this is the way to convert values into simple notation and find out the answer by using simple calculator, right? Any confusion now? Okay. Okay. Further, if we consider more question, I will send the screenshot of this one also. Okay, this is one more question related to the pressure. And in this question, we have to answer with theoretical reasons because no calculation required in this question. It shows a toy water rocket, and rocket is half filled with water and connected by a rubber tubing to a pump. Air is then pumped into the rocket so that the pressure of the air inside the rocket increases. Explain in terms of particle why the air in the rocket exerts a pressure on the walls of the rocket. So you can see this is the same type of question. We discussed that how gas exerts pressure on the wall of container. So gas can flow, liquid can also flow. So we use the same idea over here, just like we discussed. And this question is for 3 marks. So at least you have to explain 3 points. So first of all, when air is pumped into the rocket, so definitely we have some space empty in the rocket where we have air particles. So when we pump more air into this rocket, so air particle push water particles, and when they push water particles, so it creates like more frequent collision between the air and water particles. So we can write answer when air is pumped into the rocket. It pushes water and air particles present inside the rocket, and particles gets kinetic energy and collide frequently with walls also exerting force per unit area on wall of rocket. So force per unit area gives you pressure. So in this way, we can write answer for 3 marks in short form, right? So we discuss about kinetic energy, more frequent collision, force acting per unit area. So we have 3 important points in this answer. So you will get easy 3 marks because we mentioned 3 basic points related to this question. Right? Any confusion in this question?
No, sir.
Okay. Next part is the temperature of the air in the rocket remains constant as air is pumped into the rocket. Explain why increasing the number of air particles in the rocket increases the pressure of air in the rocket. So this is only for 1 mark. We know that when temperature increases, so kinetic energy increases. But right now of air in the rocket remains constant as air is pumped. So explain why increasing the number of air particles in the rocket increases the pressure of air in the rocket. So when we insert more particles into that limited area or limited volume, so that will increase the pressure because we have same volume, but we have more particles. So more particle exerts more pressure. So that will give you greater number of pressure inside the rocket. So increasing the number of air particles increases force exerted by particles. Hence, pressure also increases. Because you remember we discussed in this formula, pressure is directly proportional to the force. So if we increase the force, pressure also increases. So this is for 1 mark only. So we have to explain with one reason. So this is the reason that how it is increasing with increasing the force on the particles.
Sir, can you scroll to the answer again? I was just writing the last
Okay.
part. Okay, sir, you can scroll down.
Okay. B part of the question says, when the air pressure in the rocket is high, so now pressure increases and pressure is now high. The rubber tubing is removed. So we remove that rubber tubing from the rocket. The water in the rocket is expelled downwards. So explain in terms of momentum why the rocket begins to accelerate upwards. So this is for 3 mark and this is journal application just like the rockets. In rockets, what happens? Gas or the fuel burns out and gas comes out from the rocket that exerts force on the ground and then rocket moves in upward direction. So same thing happens over here. We pump water, air into it, and when we remove this rubber tubing from here, so let's suppose if we remove, so let's suppose rubber tubing is removed now. So water starts to come out from this rocket with high pressure. So water particles are coming out with high pressure. And question is in terms of momentum, how it helps to accelerate this rocket in upward direction. So according to the concept of momentum, momentum is mass into velocity. So you can see that the quantity of water is coming out of the rocket and it is moving in downward direction. So when it exerts force on the ground, so ground will also provide opposite force on the rocket, right? So this is action force on the ground and this is reaction force. So since reaction force in upward direction, so that's why rocket starts to accelerate in upward direction, right? So we have to write this whole concept in this answer. So in terms of momentum, so basically water particles comes out of the rocket. Exerting force in downward direction and reaction force acts on rocket in upward direction. And we know that the rate of change of momentum is equals to the force, because rate of change of momentum is called force. The rocket accelerates in upward direction. Any confusion in this answer?
No, sir.
So, T part is related to acceleration. So, right now we are not doing acceleration. We are only talking about momentum, pressure, and force exerting on the particles. So, right now, just ignore the C part of the question. We will do that part with acceleration topic when we revise acceleration, forces, velocity, etc. So, for right now, just ignore C part of the question. And if we find some more question related to the pressure only, so this is another question. A fixed mass of gas in a glass tube is trapped by a seal at one end of the tube and by a column of mercury. The mercury is free to move within the tube. The tube is rotated slowly from vertical as shown in figure 3.1 to horizontal as shown in figure 3.2. The volume of gas increases and temperature remains constant. So volume of the gas increases and its temperature remains constant. So initially we can see that this is the volume inside, and after that this is the volume inside. So volume increases. So part A is describe why rotating the tube changes the pressure of the gas in the sealed end. So when we rotate the tube, so why the pressure of the gas in the seal changes? Any idea? Okay, so basically, in vertical direction, you can see we have atmospheric pressure also. Atmospheric pressure is also acting from upside. But when we rotate this tube in horizontal direction, so in horizontal direction, there is no atmospheric pressure acting in inside of the tube or on the mercury, right? So that's why the pressure changes, because in vertical position, atmospheric pressure is acting, but in horizontal position, atmospheric pressure is not acting on the mercury. So this is the difference, right? Because atmospheric pressure is not acting on mercury. In horizontal position, so pressure decreases. Second part, explain using ideas about particle why the pressure of the gas decreases when its volume increases. So pressure of the gas decreases. Right now, we have the second horizontal diagram. In second horizontal diagram, we have more gases, we have more volume of the gas particles. And the question is, why the pressure decreases in the horizontal orientation of the tube. So when volume increases, so particles more space to vibrate and they collide less frequently, exerting less force, on particles. And wall. Decreasing the pressure. So any confusion in first or second part? Okay. B part is in figure 3.1, the length of the mercury column is 0.3 meter. The density of mercury is 1400 kg per meter cube. Atmospheric pressure is also given. So calculate the pressure of the gas in the tube. So length or height of the tube is given. Density is also given. This is atmospheric pressure. Calculate the pressure of the gas in the tube. So which formula we have to use to find out the pressure of the gas inside the tube? So we have one formula related to the liquid, which is equals to density, gravitational strength, and the height, rho gh. So if we use that formula, so density is 14,000, value of G 9.8, length or height of liquid in the tube is 0.3. 0.3 into 9.8 multiplied by 14,000. So we got answer 41160. Or you can round it off to two significant figures. Or you can also write your answer in scientific notation. So it's your choice. Any confusion, any doubt in this question? Okay, after this question, uh, we have another concept in the topic of pressure that is related to the gas laws. And that law is called Boyle's law. And the statement of Boyle's law is at constant temperature, pressure is inversely proportional to the volume. So for example, if the temperature of the gas remains constant, so if we do not change the temperature of the gas, so pressure and volume of the gas are inversely proportional. Inversely proportional means if one quantity increases, the other quantity decreases. So P inversely proportional to V. And let's suppose if we remove this proportionality sign, so we got constant value on the right hand side, any constant value on right hand side. And if we consider initial and final state, P1 V1 is equals to constant. So this is the initial state. And for final state, let's suppose the final pressure and volume is P2 V2 equals to constant. So we have these two equations, and these two equations are similar from right hand side because we have constant on right hand side, and on left hand side we have pressure and volume given. So if we compare these two equations, equation number 1, equation number 2. So after comparing these equations, P1 V1 is equals to P2 V2. And we use this equation directly for calculations in the question. Any confusion in this Boyle's law? Any confusion in the equation? Okay. So with the help of this equation, we can also find out pressure and volume at constant temperature in any situation given in the question. Okay, we have another question related to the pressure topic. A student pushes a drawing pin into a wooden board as shown in figure 4.1. The area of the pin in contact with the finger is, so this is the area, and a student pushes downward with a force of 26 Newton. The mass of drawing pin is very small. Calculate the pressure exerted by finger on the drawing pin. So the area is given, force is given, and we have to find out pressure. So formula of pressure is force upon area. So the value of force is 26 Newton and the value of area is 5 exponent minus 5. So 26 divided by 5 exponent minus 5. So the answer is 5.2 10 to the power 5. So this is the pressure exerted by the finger on the drawing pin according to the values. Second part is compare the force exerted by the finger on the drawing pin with the force exerted by the drawing pin on the wooden board. So which force you think that will be greater? Force exerted by finger on the drawing pin or the force exerted by the drawing pin on the wooden board? Because the area of drawing pin on the top is greater. So when area increases, pressure decreases. According to the formula, P is equals to force upon area. So when area increases, pressure decreases. So we have to apply more force on it. But when area decreases, pressure increases. So that will give you uh, less force. It means if we apply less force, so with the help of less force, we will get more pressure easily. So force exerted on the pin is greater as compared to the force on the wooden board because of greater area. Because the head of the pin has greater area and the bottom of the pin has a small area. So that's why we have different values over there. And explain why the drawing pin goes into the wooden board but not into the finger. So answer is simple because of large area in contact with finger exerts less pressure and the area of pin in contact with board smaller area exerts greater pressure on board and penetrates in it. And B part is related to another diagram. It shows water emerging from a plastic bag that contains a number of small holes. So explain why the water emerges from each hole in a direction at right angle to the surface of the bag. So in all diagram, you can see it is at 90° with the surface. So question is, why water emerges from each hole in a direction at right angle to the surface of the bag? So pressure of water inside the bag acts equally in all direction and force acting on per unit area of bag is at right angle to the bag. Because particle hits the surface of the bag and when they hit the surface of the bag, so they are moving in horizontal direction. So that's why they are at 90° or at right angle to the surface of the bag. And second part, the holes at part A and B are same size. Explain why water emerges faster from the hole at A than at B. So A is at the bottom, B is on the top. So you can see water emerges with greater rate from A as compared to B. We know that this is related to liquid. And according to the formula of liquid, the depth of uh, point A is greater as compared to B. So hole A is at greater depth. So that's why it exerts greater pressure of liquid at point A as compared to point B. So we can say hole A is at greater depth as compared to B. So pressure exerted by liquid at point A is greater Then B. So these are some questions and the concepts of the pressure in solid, liquid, gases plus atmospheric pressure, and we also discuss about the Boyle's law. So these are the concepts related to the pressure, right?